This is an explanation of the Microrocket Lab and why 4 hydrogens to 2 oxygens should have been the best ratio that gave you the best launch. So we've got our microrocket drawn out. I've got our unbalanced equation right now, and I'm going to fill in first off 3 to 3. So if I fill that in with oxygen, and then I fill our other 1, 2, 3 parts with hydrogen, when we look at our equation here, we know that you guys know how to balance equations by now. You should know that it takes 2 of those for every 1 of those, 2 hydrogens for every 1 oxygen, and that gives you 2 water molecules. So, boom, combustion happens up there, and 2 parts hydrogen get used up for every 1 part oxygen. So that means that this 1 part gets used up, and then a second part gets used up of our hydrogen. So that was 2 parts of hydrogen that got used up, and then 1 part of oxygen gets used up. So notice we've only got 1 part hydrogen left. We've got 2 parts oxygen. If that 2 to 1 ratio happens again, we've got 1 part hydrogen that gets used up, and since it has to be a 2 to 1 ratio, we can actually only use half of our next oxygen. So notice that we've used up all of our hydrogen. We have some of the oxygen left over. That's not a very efficient reaction because it's basically, you could have had some more hydrogen there to react with that oxygen. That shouldn't give you a great launch. Now here is 1 part hydrogen and 5 parts oxygen. I'm hoping that this was the worst launch by far for all of you, and this is why. Once again, 2 to 1 ratio of hydrogen to oxygen. So 2 parts this for every 1 part of this. Well, the problem is we only have 1 part hydrogen, so when that gets used up, it only combines with half of a part of oxygen. So I'm going to erase that. So you can see all the hydrogen just got used up, and we've got 4.5 parts of oxygen left over that are unreacted. Very inefficient reaction there. Then our last combination, we've got 4 parts hydrogen to 2 parts oxygen. Going back to our 2 to 1 ratio, 2 hydrogens get used up for every 1 oxygen. Okay, so that was our first part of the combustion. 2 got used up for every 1, and then we've got another 2 getting used up for 1 oxygen. So 2 hydrogens just combined with 1 oxygen. And notice we've got nothing left over at that point. That's a really efficient reaction. You don't have anything left over on either side. So that's why the 4 to 2 ratio of hydrogen to oxygen should have been your best combo, the 4H and 2O. If you're curious, if you're somebody who's interested in taking maybe AP chemistry in high school, what we're talking about right now is a very simple version of something called stoichiometry and limiting reagents. That's using a lot of math to figure out how much of each reactant you have based on how much you start with, if you'll have a leftover of one of your starting products. So it involves a lot of calculations to figure out, okay, am I going to have hydrogen left over or oxygen, and how much, and then exactly how much water would that produce. If you're curious about that, I'm happy to talk more about that, but that's the kind of basic explanation of our Microrocket Lab.